Welcome to Innovation Under the Stars. What a day for September. We were ready for rain and cold, and here we have this gorgeous day. So you could be anywhere, like the beach, the mountains, anywhere, but you're here with us, and I appreciate that. So thank you for joining us. We've got some exciting things to talk to you about space tonight. Who here, if a spaceship kind of like that landed right here, would want to go to space? Anyone? Like, just sign me up and go? Totally, I'm with you, I'm in. You wouldn't be here if you didn't love space, but going to space is something else. One of the things I want you to see tonight is that there are ways to interact with space, to learn about space, look up at the stars. It'll get dark while we're sitting here, so you will actually see innovation under the stars. Oh no! Come on! And then, there are ways to interact online. There are ways to actually go to space. Within your lifetimes, you will be able to buy a ticket. You can now, if you've got piles of money. But average humans will be able to buy a ticket to space. I tell my kids all the time they'll be able to buy a ticket to the moon in their lifetime, and I strongly believe that. So we're going to show you some really fun ways to learn about space. First up, I want to introduce our wonderful team here today. To my left, I have Dr. Cody Page. She's director of the Space Exploration Initiative at the MIT Media Lab. Just to my left over here, we're all from the Media Lab. She works on innovative technologies in space, and we'll be talking about them in a minute. Alyssa, to her left, Alyssa Chava, help me out here, Chava Lithamrung. Thank you so much, I nailed it. She's a PhD in our Space-Enabled lab at the Media Lab, and Space-Enabled does work using remote sensing, imagery from space for challenges all over the world. Alyssa also works on a program called Zero Robotics. Has anyone ever heard of Zero Robotics? Have you heard of First Robotics? Legos, building robotics, kids can do it, anyone can do it. Zero Robotics is a way to build and design software that fly robots around in space, and she'll be telling you a little bit about that. To her left is my colleague Rachel Connolly. She's a former physics teacher and is a scientist at the Media Lab who does research on Earth observation and how citizen scientists can get involved in NASA technologies, and how we can use the massive amount of data streaming back down to Earth from space to inform things like climate change and all kinds of other Earth concerns. So welcome. Give a round of applause to our team. All right, Cody, I'm going to ask you first. The Media Lab, for those of you who know it, is interdisciplinary. We are an MIT laboratory, but we pride ourselves on putting researchers of all different backgrounds together. So if we had engineers working on space in a room, you would also see artists and designers and musicians. And from those different perspectives, we find we come to the best solutions. You can imagine on any given day in work or school, the more perspectives you have, the better solutions you have. You want to hear from all different minds to come up with the best answers, and we live and breathe that every day. So Cody, in your Space Exploration Initiative, how do you apply the multidisciplinary approach to your work?
So let me back up a second, and I'll describe to everybody what the Space Exploration Initiative is a little bit. We're different than a lot of labs at the Media Lab in that we get to work with students across the Media Lab, MIT, and Harvard. Any of the researchers there who are working on something that's space-related, we help them to put their experiments into space. And we do it in different ways. We work here on Earth, we do prototyping, we build different components, and we have this program that essentially helps them to build towards getting into space. But one of the real benefits of getting to work with all the different labs across the Media Lab is that we really get to work with all of these multidisciplinary people. So the Media Lab has researchers that are doing things from anywhere from designing musical instruments to working with Lego to creating implants that can go into your brain or bionic limbs. So really just a huge spectrum of experiments, and a lot of those have application in space. So we work with those students and we help to bring out all of those different aspects of what it really means to live in space. And being multidisciplinary like that, we can think about not just the technologies that we need to get into space. Like, yes, we need rockets and, we need rovers to go on Mars and explore, but we also need culture and we need humanity. We love that we get to work with artists. We love that we get to work with musicians and architects. So all sorts of different people. And we're thinking about the culture that we're bringing into space and not just the technologies. So thinking about humanity's future in space.
That's wonderful. Another part of your work that I find so fascinating is we're aiming for the moon, NASA, commercial space, humanity. We're getting to the moon, and not just because the moon is an interesting place, but also because it's a way station for exploration further into the universe. So to get to Mars, it would be really convenient if we had a space station on the moon and we could build a station there and start launching to other planets and deeper into space from the moon. So a lot of NASA's missions are headed towards the moon, back with people, and not just to land and plant a flag, but to stay. And some of Cody's work is heading towards that too. There's this really interesting phenomena of lava tubes on the moon, if anyone's heard of this. We've recently discovered that when you look at the moon and it's all pockmarked and you see these circles, with the imagery and the data we have from the moon, it's really hard to tell if those are deep crevices or they're mountains or they're circles. Some of them are actually holes that got broken through the moon's surface, and underneath them are these big cavernous lava tubes. And the reason that's important is as we go towards building stations on the moon, we need a place to be protected from the sun's radiation, from other comets and things, debris hitting the surface of the moon again. So these lava tubes are a super interesting place scientifically. Cody's done some work using land, what we have here on Earth, as an analog to the moon surface. So we don't have to just get there and study, but we can work here to start to figure those things out. So can you tell us about some of that work?
Yes. So most people don't know what lava tubes are. I'm a geologist, so I love talking about rocks. I love talking about the Earth's formation. So I'm going to give you a little bit of a geology lesson here, but it'll be fun, I promise. So when volcanoes erupt, the magma comes out the top of the volcano, and as it's flowing down the side, it will sometimes find little cracks in the side of the volcano. And as it divots into those cracks, it kind of burrows its way through and creates these tunnels underground. And the lava has this almost crust around it as it's forming these tubes. And so the magma is flowing, the lava is flowing, but eventually the volcano stops and the lava continues to flow out, and that crust remains. So you end up with these underground tunnels that can be incredibly long and very large and very difficult to explore. And it just so happens we have them on Earth. There are on other planets in our solar system, and we think they have them on the moon as well. So when we want to come up with technologies to be able to explore these places, we need to test the technology here first and make sure that it works. Going to space is very expensive, it's very difficult, we don't get to do it very often, and once something gets to the moon, you don't get to fix it. It has to work once it's there. So we actually went to the Canary Islands. We went to Lanzarote, which is part of Spain, off the coast of Morocco. And they have some incredible lava tubes there that we got to explore. And we took 3D cameras. So these are cameras that can tell you the depth of something as well as the regular picture. So it's what you might think of in virtual reality. So we can get these 3D pictures of a lava tube and understand if the technologies that we have will work in these very dark, underground, very hard to reach places. And we want to then be able to send these cameras to the moon and to be able to explore these hard to reach places with these cameras that we were testing.
So cool. So even though it would be fun if a rocket ship landed right here and we could all go to space, think of all the ways that you can actually take advantage of places here on Earth to start that research. It's really phenomenal. Alyssa, here's another way our friends here can get involved. Can you tell us a little bit about Zero Robotics and how it works?
Yeah, so Zero Robotics is a STEM outreach program. It's a robotics program where kids will write code for a space robot on the International Space Station. And the International Space Station isn't just like a hunk of metal that astronauts live on. It's actually a laboratory. It's a place for research and development and education. And on Zero Robotics, we work with Astrobee, which is this little cube-shaped robot that could kind of float around the International Space Station. It's a free flyer, so it propels itself with little fans. Little fans. And during the summer, teams of students from across the country, right now middle school students, can get to write code for the Astrobee.
And so when students do that, when middle school students, it's just a graphical programmer. So if you've never written code before, that's okay. You're dragging and dropping boxes and you're actually flying a robot in space. After students finish their work over the summer with the program, then what happens with the finals?
Yeah, so students get to put their code on the International Space Station. So usually in August, teams will form these alliances, and they will get to actually physically run their code live on the International Space Station. It's a really cool experience because astronauts will be there narrating. You can interact, and you actually can talk with the astronauts and ask them questions.
Yeah, when you work on experiments in space, sometimes you get a minute or two to talk with the astronauts through a live feed to ask questions. You know, how does this look? Can you push this button? Can you change this thing? But for Zero Robotics, we'll have 6 hours, 8 hours of astronauts on the screen. These kids come and go, they chat, and the astronauts are just there all day because they love the program. So imagine the first time you program something and it goes to space and the astronauts are telling you what a great job you did. It's really a wonderful program. Any special memories from students or anything that you think memorable from the first time you did it?
Well, this summer was my first year actually working on Zero Robotics. It was just a really cool experience because I feel like Zero Robotics, it's a way to make space like tangible for people. I feel like by actually giving students the tools to engage with space, these traditional barriers that people have, it kind of disappears a little bit. Space is something that students and young people can actually engage with and experiment on and be a part of.
Yeah. This QR code, by the way, we're trying to show you some of the actual work. These are the Zero Robotics students from this past summer. This QR code will get you back to our website, and we'll tell you at the end, or come back and see us if you want to get involved in the program. The high school version of the program is actually writing code, and that runs through the school year. The middle school program runs through the summers, and it's open source. So if you are a mentor, a teacher, a scout leader, you could put your own group together and run a program. So we'd be happy to talk about it more later. It's one of our favorite projects. Rachel, you're waiting so patiently. Rachel, tell us a little more about citizen science and another way people can get involved by using data, big data, data visualization. How can people really see from all of the assets in space things that are happening here on Earth?
Testing. Yeah. Thank you. So I want you to think about the last time you felt this really strong connection to the universe, some sense of awe. It might have been an image like the Earthrise image. It might have been, who here saw the solar eclipse this last spring? Yeah. So you might have experienced a solar eclipse or at a celestial event or looked up at the sky, or perhaps you saw it on television and you watched, in this case, a flyby of a planet, or you saw some amazing mission data on that. There is so much data out there we keep hearing about, but there's stories that are also coming from these satellites that are opening up new ways to connect with the universe. And that's really what I want you to take away from this, is these satellites, this data, and this is actually just from a few days ago. These are just the Earth viewing satellites that are orbiting, that are part of NASA's fleet. There's over 1,000 satellites just looking at our Earth, and there's over 10,000 satellites going around. But they're telling new stories, and this is a couple of examples here. This is the Earth. We call it the beach ball because you can see all these different stripes. But you can see things like vegetation and the forests breathing and growing over the seasons. You can see things like actual ocean surface temperatures, precipitation. You can even see active fires. There's some amazing things that our planet, we're starting to learn about it just because of all of this new data. This is another thing you've probably seen. This is the sun, but this is the sun in many, many different views. Your eyes can see a very small percent of all this light, all the kinds of light in the universe. If we're one piano, there's 50 more pianos that we get to not see with our eyes, but the satellites get to see. The same thing advancing your phones and your cameras are also advancing our telescopes. And all of these tell us different things. You can see here, those are all those slices, but broken out. Every different view is a different event. It's a different part of the sun. You'll notice that it says Kelvin, that's a temperature. And you can see that as the numbers go up, the temperatures go down. So we're seeing different parts of the sun with the light. And we can do this here. We can take a journey, a data-driven journey, all real data, from here to the edge of the observable universe. So I'm going to take you on that journey now. And everything here is not artistically well, it is artists who rendered it, but it's all from real data. Billions of dollars of telescope and satellite data in one virtual universe. So we have left the Earth here. You can see as we pull away, what do you think the first thing we're going to see is? There's your moon. Right there. There's the moon you guys want to go visit. 1 light second away from us. And then as we pull out in our inner solar system, you can start to see the orbits and the other inner solar system planets start to appear. So we're about 1 light minute from Earth now. And as we pull out, you can see the other planets around the sun. And you might notice they're all in a flat plane, right? Because they all formed out of a disk together. So that's a story of our evolution. There's thousands of asteroids in the asteroid belt there. And as we pull out, you can see the icy Kuiper belt objects in the outer solar system. These are the most distant spacecraft, the Voyager spacecraft, that we physically have out there, that we've sent out into space. And now you start to see the sun, and it starts to blend in. We're in interstellar space now. So we've got the other stars around us. And as we start, we're about 10 light years away. So if you're under 10 years old, we are now, sorry, you have not been born yet, okay? So as we pull out, you can start to see the other stars around us. There's a star cluster called the Hyades we're a part of there. And now this is the most distant that our radio signals have traveled out into space. So anybody inside that bubble has heard us if they're listening. All of those asterisks are exosolar planets that we've discovered. And as we start pulling out, that little bubble's still there. That is our presence in the universe. Anybody outside of that has yet to hear us yet. Again, if they're listening. So that little bubble, as we start to pull out, you can start to see this big gas and dust cloud. That spiral is our galaxy, the Milky Way galaxy. So we are now in intergalactic space. All of the dots you will now start to see are not stars, they're other galaxies. 100 billion galaxies, each with 100 billion stars in them, give or take. And then as we pull out into intergalactic space, you're going to start to see the structure of the universe take shape. Again, all of this is data taken from satellites and telescopes. So now you're going to see something really interesting. You're going to see some slices because telescopes look out in slices at the sky. You're going to see this area here, this V, that you don't have anything in it because we can't observe it through the dust and gas of our own galaxy. So I took you to the edge of the galaxy or the universe. So now, how do you connect to the universe? This is where citizen science comes in. There are apps now, there's data. The satellites need your help. Sometimes they need you here on the ground to say, I can tell you how high these trees are because you looked from above and you need to know from below. So they help us, we can ground truth the satellite data. We can add to the data that they have from space to bring out the full model and picture. You can look at clouds. In this case, you can say, what does the sky look like here? Because guess what? Climate change is impacting our cloud cover, and the satellites really need help measuring clouds. So you can just here make an observation on your phone of your clouds where you are. You can do all kinds of amazing things if you want to go to. There's a couple of great places. NASA has a citizen science page with all kinds of projects. Here's another one, Aurorasaurus, that you can report an aurora, or you can go through a bunch of other aurora reports and see which ones are valid. You can tell them this is a real report. So you don't have to have a phone. You don't even have to make an observation. You can help them with data. And right here, this is one of my favorites. If you scan that QR code right here on your phone right now, you will get a actual Earth that you can, this is just from like a few days ago, so you can actually see there the Hurricane Helena forming in the Gulf Coast that unfortunately is making its way across the southeast United States right now. This is a very quick and easy way to select and look at wind, ocean currents, almost in real time from our planet. So I hope you enjoy.
Really fun stuff. Also following us tonight, we're not done yet, but when we are, there's another program happening right after us where you can look at telescopes and look at the stars. Rachel, is there something about a moon viewing coming up in the next few days?
Are you talking about the new moon we have? Yeah, we picked up another moon for a couple months. This happens thanks to gravity and the fact that sometimes they wander a little close to us. I know a scientist I used to work with who said that asteroids are the universe's way of saying, we hope you have a good space program. Because if you're not monitoring them, sometimes they wander by and occasionally they could hit you. So you like to know what's coming. But we picked up a new moon for about a couple months, and it's not going to be easy to see, but it's kind of nice to know we've got a dual moon now for a little while.
Yeah. So whether it's an app online, a telescope in about a half an hour, or just looking up at the sky, look up that new moon, you can, with your own eyes, just see some really interesting things happening in space. So I want to go back to the Media Lab, where we're from, and talk about this multidisciplinary way we approach problems. We tackle big global challenges, and we feel like we want the best minds together to do that, and the best minds often come from really different places and cultures and ways of thinking. So in order to solve those problems, we need these very diverse teams, and I can't help but notice that there are all women up here, but for most of my career, I was often the only woman in the room. So I want to hear from all of you. How has being a woman in a largely male-dominated field, and Alyssa, I hope for you, we're finally knocking out of the park, and we've got all kinds of men and women involved. I know one of our AeroAstro programs at MIT now has more women than men, and certainly more diversity than ever before. How has being a woman in this field impacted your journey? Rachel, I think if I could start with you, you have a good story. I know it was just your turn. I'm putting you back on the spot. Do you have a good story about a professor I've heard before?
Yes, thank you. I appreciate that. I think I was in college before you were born, so this is why I'm going to start first. I was an undergraduate physics major, and I was the only female physics major the whole 4 years I was an undergraduate student. And there was one professor who was, she had went back to college and gotten her PhD. She was an astronomer after she raised her family when she was, in her later in life. And having her as my astronomy professor and a model, and just the representation and knowing you can do it with the family, you can do it in diverse ways. She didn't treat me different, but it just being there really helped. And years later, as a science teacher myself, I started teaching high school, and I was the only female physics teacher. There were 3 other male physics teachers. And when I joined the school, there was one second-year AP physics class, and it had 12 boys in it. And I remember this. When I left 5 years later, there were 3 AP physics classes that were almost half and half women and girls and boys. And I didn't really realize it until the department chair said, you realize this happened because they had a teacher, they thought they could do it, and they're doing great. And I have to tell you, I never thought of it until then, and I was faced with it. So I've experienced it as a student, and I've been honored to see it as a teacher. So being in this environment has just been, it's been wonderful. And I really hope, I want you to tell your story, because hopefully it has led to this.
Yeah, Alyssa, has it not mattered? Have you not noticed? What is it like from your point of view?
Well, so when I was in high school, we had a welding program. And I loved welding. I actually did it all 4 years of high school. Like, just being able to like have this box of electricity and like fuse metal together, like it made me feel really powerful. um, and a part of this welding program was like a STEM outreach thing where we got to build like a moon buggy. And it really solidified why I wanted to go into engineering. But what was hard about it was that there was only one other girl in the program. And it felt hard for me to feel like I could make friends or felt like I like really belonged. Especially when you're a girl and like going through high school and it's just boys around. But through Zero Robotics, I felt like I had this opportunity because I really remember vividly what it was like being a girl. And I think what we want to do is add or have more girls join this program and kind of target Zero Robotics towards girls and other minorities, because I feel like when you give kids the chance to do this when they're young, they feel like they could do it when they're older, and you could see more diversity by that.
Yeah, thank you so much for that. And boys too, we want you
Boys,
to.
yeah.
And you don't know if you like it or not until you try. I think that's one thing that comes out of the Zero Robotics program is some people don't love it, and that's okay too. But it's an interesting phenomena to be able to try something new and realize, well, I can do this. Everyone else is doing it. Why couldn't I? And the program really teaches you that you've got that inside you. Cody, any thoughts?
Yeah, I grew up. I have two sisters. I'm in the middle. One sister's a dentist and one is a vet. So obviously we got pushed to do a lot. And I think because of the family that I grew up in, I always felt like the opportunity to do whatever I wanted was there. Yeah. And so when I got interested in space, the limitation for me in my brain wasn't that I was a girl. It was, well, how do I get into space? How do I connect to space? Like with things like Rachel's talking about, how do I do that? And going through university, I was one of two women in my program. Then working in the engineering field for a while. I was designing airplanes, and I was one of very few women. And then actually, as time went by, it started actually to get more and more women. And now here at the Media Lab, even at AeroAstro in my lab, we were, I think, more than 50% women in the space field. So now I feel like there are a lot of women who are doing this, and hopefully having us here makes other women and girls feel like this is something they could do. But I've also noticed you talk about multidisciplinary, and part of that I think is that women and men, girls and boys, might have different interests, and making sure that we have all of those interests represented in space is really important. So like I talked about the musicians and the artists as well as the engineers and the scientists, and knowing that there's a place for all of those people, and that we want everybody and all of your thoughts, all of your ideas to go into space exploration. I think that is a really big part of making sure that we have this really amazing, diverse group of people that are thinking about where space is going.
Absolutely, for sure. Thank you so much for that. And it's true, sometimes the solutions to all of the really big challenges we have to get to space and do research in space and explore further aren't just the engineers. It's the people who do the communications, or the lawyers who keep the contracts sound, or the artists that tell the stories about it. So those people inform the actual design and experiments, but also there are all the peripheral businesses that surround it. So teachers, artists, we want them all. So stay with us. I think we have time right now for questions. Anybody have a question? And if you do, either come on up or shout it out and I'll repeat it to the crowd. Any questions about anything you heard tonight? Over here.
Will we be able to see it? Will we be able to see the second moon with our eyes, or will we need telescopes?
It is very small. It's small and it's dim, so I don't think you'll see it with the naked eye. But this is a good maybe telescope opportunity, or NASA. I'm sure will have some great pictures. Amateur astronomers are key here. They love taking photos of this. There's a great site. I don't know if you've heard of it. It's called Astronomy Picture of the Day. APOD for short. Every day, different image, and they will have images like this. And it is NASA's #1 most popular page. It's amazing. So, Astronomy Picture of the Day. Check it out.
Fantastic. In back.
Good afternoon, all. Thanks for the invitation. This is for Alyssa. If I'm correct, Alyssa, you were speaking about micro zero gravity. How do you emulate and simulate it on Earth? Can you explain, if you don't mind, please?
Yeah, so we have an online platform that we have calibrated to imitate the microgravity on the International Space Station. So we take all this data that we've gathered from Astrobe and we kind of condense it into a program. So when kids test their code here on Earth, it's as lifelike as possible.
Okay, one more question.
I'm fascinated on the exoplanets. Can you tell us about that?
Sure, I'd be happy to. So exoplanets are planets that we have discovered orbiting stars beyond our solar system. And it's interesting because our understanding of exoplanets, which you'll see here shortly, has really evolved with our technology. So as our telescopes get better and better at seeing things more and more, precise and accurately, we are better and better able to start to see the exoplanets. And really the way we detect them is we look for these little wobbles. Like you can imagine that the planets going around the stars kind of tug at them because of gravity. So you look for the little wobbles in the stars, and those wobbles tell you how the orbits are. And as we have this amazing telescope that was put up called Kepler. And it was put up just to look for the wobbles. And with Kepler was this explosion of thousands and thousands of exoplanets that we have started to discover. And we're able to even see sometimes when the exoplanets are Earth-like, if they're the right mass and they're the right even atmosphere. You can actually see when they pass in front of the sun, their star. You can look through their atmospheres, kind of like looking through a filter, and you can see what elements get filtered out, and that tells you what elements are in their atmosphere. So you can even look at their atmospheric thumbprints, if you will, and see if there's water in the atmosphere or oxygen. So not only have we now started to see thousands of exoplanets out there that have been discovered, we can even see the ones that might be Earth-like and even what they might have in their atmosphere. So I hope that answers your question. There's an exoplanet counter that NASA has. Literally, you can look up NASA exoplanets, and if you go to the site, it's 6,000 and so many exoplanets currently discovered. So keep watch of the count. And there is a citizen science project that helps look for wobbles and detection. You can look at the light detection and say this might be an exoplanet candidate. There are kids who have actually discovered their own exoplanets. So get on it, that site, and get started, because you might find an exoplanet too.
Cool stuff. Great question. Thank you. I'm going to use my privilege, because I have a microphone, to ask my own question. We talk a lot about going to space and the astronauts float around, and that's microgravity, where most Earth, like the space station and where the space shuttle was, are all in lower Earth orbit. That's about 200 miles straight up from here, kind of like if you were going to drive to New York, but instead you went straight up. So most of the stuff you see with astronauts is in low Earth orbit, and we've seen people buy tickets, like Jeff Bezos put a vehicle and fly himself to space and back, and is that really space? How far it is? And then there's this sort of microgravity research we do. So this thing we keep showing you on the screen is actually an airplane that flies. It's not up in space. It's right here on Earth. Have you ever been on a roller coaster or at least an elevator? when the elevator comes up and then you hit your floor and it kind of sinks down, do you do that thing where you jump up and you get like a little lift? I still do that. I learned it when I was a kid. But the plane that does this flies in parabolas, kind of like the shape of a roller coaster. So when it gets to the top, everyone kind of gets thrown up into the air for about 20 seconds and they float around. So this is microgravity, but it's not all the way up in space. So it's a little confusing, but that's how we can emulate it here on Earth to do some of the early research, like Cody mentioned before we go all the way to space. Cody, can you tell us a little bit about the research you do and what it's like being on a plane like this?
Yeah, this is super fun and really cool. And if you ever get the chance to do it, do it. But if you've ever heard of the vomit comet, that's what they lovingly call this airplane that does these parabolas, because it can make you a little sick, but they're really fun to do. But the great part for us is we actually get to test our experiments in microgravity or zero gravity, the same zero gravity that they would have on the International Space Station. And we get to make sure that they work in those conditions before we send them to the International Space Station. So all of these things you're seeing here are experiments that we want to one day actually put into space. And these are beginner parts of the experiment that we're just making sure all the parts are working and everything's going to be functioning once it gets to the space station. And the pilots who do this for us are so incredible that they can not only do zero gravity, but they'll also do lunar gravity for us and Martian gravity. So we can test things for different planets and the moon. And you can see how a lot of people actually really struggle when they're doing this. People are kind of flying all over the place. The first time that you do one of these parabolas and you start to float, you don't realize that you could touch the side of the airplane and you will fly off to the other side because there's no gravity holding you down anymore. So you need so little force to move around. So you can see it's actually hard for people to do their experiments on these flights, but they manage.
So much fun. If you've ever seen a movie of people in space, The Martian, Apollo 13, all of the space movies, if you watch them and it looks like they're floating, they probably didn't really go to space with the entire Hollywood studio. They were on a plane like this. So if you watch, you can see here how we said it's about 20 seconds. So you can see them floating, they take off, and you can see they're near the end, things start to sink. So if you watch the footage in any space movie, you'll see none of those shots are longer than 18 or 19 seconds. And if they're taking off their gloves, you'll see the gloves float and then slowly start to stink. And now you'll know how that was done. Really cool stuff. Any more questions? All right. Well, I am going to thank our panelists. Thank you so much for being here, and more importantly, for all the important work you do for space, for Earth, for students, for inspiring people here, people everywhere to do important work in space. Let's give them a round of applause. Thank you so much.
Thank you, Kim.
Yeah. And I'm going to ask all of you to do one thing in your day, in your week ahead, that's either gazing up at the stars. You could stay for the session that starts after this in about 20, 25 minutes and look through a telescope, look online, find some way that you can engage in space. Even if it's staring up at the stars, there's an app called Star Walk that'll show you all the constellations, and realize that this big, wonderful, beautiful thing called space is something we can all grab and access and be inspired by. Thank you so much for being here.